10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Hello everyone, this is Professor Vincent Torre Bongolan, and in this video, I will walk you through how to construct a frequency distribution table. Alright, so the easiest way and the most organized procedure before calculating the measure of central tendency and measure of variability for group data is to construct a frequency distribution table.
Oh, namumula ka na.
Hello everyone, so I am here now at my condominium unit in Cubao, and I would like to do a quick demo of the Internet of Things and the AI application that is developed for my condominium unit.
What is Digital Week?
The Digital Week 2019 is an ADB annual.
Hello everyone, this is Professor Vincent Torre Bongolan, and in this video, I will walk you through how to construct a frequency distribution table. Alright, so the easiest way and the most organized procedure before calculating the measure of central tendency and measure of variability for group data is to construct a frequency distribution table. Alright, so this is the first part of the video lecture presentation. Let us define what is all about the frequency distribution table first. A frequency distribution is the organization of a dataset into contiguous, mutually exclusive intervals so that the number or proportion of an observations falling in its of the interval is apparent. Frequency, on the other hand, is the number of occurrences of a particular item in a dataset. Alright? There are two elements of a frequency distribution table. The first is the set of categories that makes up the scale of measurement. The second is the record of the frequency of the individuals in each of the categories. Why do we need to construct a frequency distribution table? When we do a frequency distribution, it helps us to assist in choosing the appropriate test statistics or statistical methods to use. Alright, so we can be able to decide whether we need to use a parametric statistical methods or a non-parametric statistical methods. Second is we can be able to transform ungroup dataset to a group data. And lastly, we can be able to identify and to determine the number of outliers. A frequency distribution table, data are summarized into a frequency distribution to make the presentation more meaningful and to facilitate the analysis. A frequency distribution can show patterns of variation, which are important in making policies and decisions. Frequency distribution deals largely with quantitative observations. Alright, so this is an illustrative example. Number 1. The following data give the results of a sample survey regarding the behavior of 30 students of Statisticsdoctor consultancy inside the classroom. The letters A, B, and C represent the three categories, which are the excellent, fair, and poor, respectively. Alright, so these are the data below. This is the solution. The categories are the letters. Record these categories in the first column, then read each result from the given data and mark a tally, denoted by I, in the second column next to the corresponding category. The tallies are marked in blocks of 5s for counting convenience. And lastly, record the tallies for each of the category in the third column, This column is called the column of frequency. So this is just the numeric value of the tally. Alright, so in the illustration number 1, there are 3 categories that represents the behaviors of the students, namely A, B, and C. These letters corresponds with the excellent, fair, and poor. Second column is just the manual counting, just like counting of votes for certain candidates for a specific position. Thus, there are 6 participants under category A. There are 9 participants under the category B, and there are 15 participants under the category C. Frequency, as I've said a while ago, is the numeric representation of the tally or the count. Alright, so this is the illustrative example number 2. Since the global pandemic outbreak started, the number of patients being sent to the hospital are very alarming. Patients are coming from different places because of the unavailability of the hospitals to accommodate the influx of cases. The Department of Health decided to visualize the volume of patients for the past 110 days. Alright, so this is just a dummy data. This is not a valid and correct survey by the Department of Health. Alright, so this is just an illustrative example. These are the number of patients being sent to the hospitals or being hospitalized. For day 1, there are 904. For day 2, 645. Day 3, 43, and so on and so forth. So, this is the procedures in constructing a frequency distribution table. So, the first is calculate the range. Okay, so compute for the range first. Range is the difference between the highest value and the lowest value in the distribution. Okay, if we go back to the data, the highest value is 904 and the lowest value, 909, sorry, and the lowest value is 39. So, if we get the difference between 909 and 39, that would be 870. Okay, so the range is 870. Second step is calculate the desired number of classes. Now, in identifying or determining the desired number of classes, there are 3 approaches to choose from. Okay, this is not necessarily you need to apply all of these approaches. As you can see, there are 3 approaches that we can use. All right. So the first approach is to the 2 to the k approach, wherein the result should be greater than the range. The second one is through the logarithmic approach, and the third one is the a priori approach. Okay, so let's apply one by one. For the 2 to k approach, or 2 to the kth power, should be greater than the range. So this is a trial and error approach, wherein if you replace any value to represent the letter k, make sure that the result is greater than the range. The computed range is at 870, right? So the result should be more than 870. Thus, make sure to come up with any value or any number to represent letter k. So let's try replacing k by 9 and replacing k by 10. So if we replace k by 9, the result would be 512, which is less than the range. So we are not able to, satisfy the requirements. If we replace k by 10, the result is 1024 or 1024, which is higher than the range. So meaning to say, if we use 10 to replace k, we were able to satisfy the requirements. So again, 2 to the kth power, wherein the result should be greater than the range. Okay, so in this approach, the desired number of classes is 10. The second approach is logarithmic approach. So the formula for the logarithmic approach is 1 plus 3.33 multiplied by the logarithmic of n. Okay, so 1 and 3.33 is constant. This is approach, this approach is very subjective and based on the number of observations or data set. In our example, we have a total of 110 patients or 110 days rather. Okay, so applying the formula 1 plus 3.33 times the logarithmic of 110. So the result would be 7.79 if we are going to use 2 decimal places. But if we are going to use whole number, then we can choose 8. Alright? So using the logarithmic approach, it suggests that the desired number of classes to use is 7.79 or 8. Okay. And this is the last approach, the a priori approach. Okay. So this approach is based on the analyst's preferred number of classes. The only guidelines here is that the class should be odd numbers. The analyst may also consider the number of observations and decide accordingly. Since there are 110 observations, we can decide to use 5 as our number of classes. Again, there is no specific rule here. Okay, so the third steps, okay, letter C, calculate for the class width. Class width is the difference between the upper limit and the lower class limit. To compute for the class width, simply divide the range by the number of classes. Okay, so the range is 870. And remember, in the previous slide, we are choosing a priori approach. And based on the a priori approach, we decided to use 5 as the number of classes. So 870 divided by 5, that would be 174. So the width is 174.